Hello all, this is Kajwali Chupak Prem. I am doing my BTech course in IARE, Institute of Aeronautical Engineering and Research College at Tunigal, Hyderabad. My roll number is 22951 A6216. My subject, the course I've taken is Computer Science and Engineering, specialization in Cyber Security. And today I'm going to present you a topic that is AAT Tech Talks, and the subject I chose is Applied Physics. The topic is quantum networking and internetworking. Unleashing the quantum world, exploring the potential benefits and challenges of quantum networking and internetworking. Introduction to quantum networking and internetworking. What is quantum networking? Introducing the concept of quantum networking to students and educators studying computer science or physics with an interest in quantum technologies. Here is the picture of some quantum networking. Quantum networks use uniquely quantum phenomena like superposition, no cloning, and entanglement that are not available to classical networks. Before the photon is measured, it exists in a superposition of all its possible quantum states, each within a corresponding possibility. They use uniquely quantum phenomena like superposition, no cloning. Quantum networks form an important element of quantum computing and quantum communication systems. Quantum networks facilitate the transmission of information in the form of quantum bits, also called as qubits, between physically separated quantum processors. A quantum processor is a small quantum computer being able to perform quantum logic gates on a certain number of qubits. Quantum networks work in a similar way to classical networks. The main difference is that quantum networking, like quantum computing, is at better solving certain problems such as modeling quantum systems. Here we see, before using the classical networking, they are using the quantum networking. In 2021, there was a recent model that is the first one, but soon quantum networking is going to be fast and it's going to be implemented all over the world. It is exponentially faster than the present classical networking. Here is a picture to represent it. They're using satellites. We can also emit the quantum signals. What is quantum internetworking? Introducing the concept of quantum internetworking in relation to quantum networking and networking. Building a quantum internet is a key ambition for many countries around the world, such as a breakthrough will give them a competitive advantage in promising disruptive technology and opens new world of innovations. Laying out a step-by-step strategy to make the quantum internet dream come true, as it is much faster and it will metamorphosize the entire way of our life, says the Department of Energy. Quantum internetworking, we can see the picture here. It is a very complex process. There is a satellite that for transmission of quantum states to from ground stations. Then we have many ground stations such as GS1, GS2, GS3. And from GS1, the uplink or download channel will come to the satellite. And from GS2, it will go to the satellite and come through also. And from GS3, it will go and come, and through LAN connections will be placed. And through classical computer, we can see that the connections will be placed, and GS is ground station. The lock systems where we see are the quantum key distribution, and the dots are N nodes. These help the quantum internetworking, and it is much faster than the classic internetworking. How does quantum networking differ from classical networking? Information encoding. Classical networks use binary encoding, while quantum networks use quantum encoding that allows for superposition and entanglement. Security. Classical networks rely on encryption algorithms, while quantum networks use the principles of quantum mechanics to enable unbreakable encryption. Transmission. Classical networks transmit information using classical bits, while quantum networks transmit information using quantum bits, qubits, that can be in multiple states simultaneously. Quantum networks have the potential to be much faster than classical networks due to the ability of qubits to exist in multiple states simultaneously, so it's exponentially fast. Here are a few other differences between quantum and classical networking. Quantum networking relies on the principles of quantum mechanics, while classical networking relies on the classical of physics and electronics. Quantum internetworking allows for the... Here are the differences between quantum internetworking and how does it differ from classical internetworking. Quantum internetworking also allows for the transmission of quantum information between networks, while classical internetworking only allows for the transmission of classical information. Quantum internetworking also enables quantum teleportation and quantum routing, which are not possible in classical internetworking. Quantum internetworking enables secure communication through the use of quantum key distribution and quantum cryptography, while classical internetworking relies on conventional encryption methods. Potential benefits of quantum networking and internetworking. Quantum cryptography. Introducing the concept of quantum cryptography in the context of quantum networking and internetworking. Quantum cryptography uses quantum mechanics to secure communication channels and offers unbreakable encryption methods based on the principles of quantum entanglement and uncertainty. Quantum key distribution. Explaining the concept of quantum key distribution in the context of quantum networking and internetworking for students and educators studying computer science or physics with an interest in quantum technologies. Quantum teleportation. Explaining the concept of quantum teleportation in quantum networking and internetworking. Quantum teleportation is a technique for transferring quantum states between two parties without the physical transform of a quantum particle, and has a potential application in secure communication in quantum computing. Quantum teleportation. Here is a picture. We can see it is a very complex process in the left pic. It's so very mind-boggling, and at the same time, we get amazed by the picture. As the quantum teleporting is very complex, yet it is very mesmerizing to see it and to witness it. We can see the particle from this point to that point is transversing in a fast manner and just not traveling in a straight line, but it is disappearing and then immediately appearing at the same time and also transferring at the fast pace. So quantum teleporting and quantum routing are also parts of the quantum internetworking that makes it very fast and indifferent from the classical network. Here is the way how it works, the quantum teleporting. Photon with quantum state phi is phi greater than A, 2 bits classical channel EPR pair, and B. And here is another one which is photon with quantum state phi greater than, and A to B are the transverse points, and the point travels from A to B in a very fast pace and not in a straight line but in a zigzag line in a very very fast pace. That looks like it disappears, but no, they are actually traveling. So it makes the internet working more faster. Introduction to quantum routing. Introduction to the concept of quantum routing in the context of quantum networking and internetworking. Quantum routing. Here is the big example of quantum routing where we can see the repeater node, client node, detector station, classical and quantum photonic channel, fiber optic cable labeled with the examples of protocols. And here it is a very, very, very complex subject, and it's a very complex process where we see local control gates, qubit mapping and storage, quantum memories, triggers and sync, where traveling through the channel and they're entering multiple 4-way repeater and other repeaters, and also parrot cock, and also 3-way repeater, Duan Kimball, which is the example of it, and single photon detector, and channel from node, they are photon detectors, and they are 50-50 beam splitters. This quantum routing is very important, and it also makes the internet much faster than classical internet work. Challenges and limitations of quantum networking and internet working. If something is coming for free, there's definitely a problem in it. And so does this have many problems, as it is much more faster, but there are many disadvantages. Now let's see the challenges and limitations. Explaining the concept of quantum decoherence in quantum networking and internet working. The loss of quantum incoherence due to the interaction with the environment, leading to the breakdown of quantum superposition and entanglement. Introduction to quantum error correction. Explaining the concept of quantum error correction for students and educators studying computer science or physics with an interest in quantum technologies. Quantum entanglement distribution. Explaining the concept of quantum entanglement distribution. Quantum entanglement distribution is a fundamental concept in quantum networking and internetworking, enabling secure communication and quantum teleportation. Quantum repeater technology. Introducing the concept of quantum repeater quantum repeater technology, introducing the concept of quantum repeater technology, exploring the challenges and potential benefits of quantum networking and internetworking compared to classical networking and internetworking, future directions in quantum networking and internetworking. To discuss the potential benefits and challenges of quantum networking and internetworking, how do they differ from classical networking and internetworking? Quantum networking and networking, summary of key points and conclusion. Quantum decoherence is the loss of quantum coherence, the process in which a system's behavior changes that which can be explained by quantum mechanics to that which can be explained by classical mechanics. It is the loss of quantum coherence. Quantum coherence is the idea that an individual particle or object has wave functions that can be split into two separate waves. That's a disadvantage. Quantum error correction (QAC) is used in quantum computing to protect quantum information from errors due to decoherence and other quantum noise. Quantum error correction is theorized as an essential to achieve fault-tolerant quantum computing that can reduce the effects of noise on stored quantum information, faulty quantum gates, faulty quantum preparation, and faulty measurements. This would allow algorithms of greater circuit depth. And classical error correction employs redundancy. Quantum networking and quantum internetworking relies on entanglement distribution between distant nodes, typically realized by swapping procedures. However, entanglement swapping is a demanding task in practice, mainly because of limited effectiveness of entangled photon sources and Bell state measurements necessary to realize the process. So that is why it is one of the disadvantage also. Before we go to conclusion, here are few of the conclusions, the topics. Distributing quantum resources such as an entanglement and qubits over long-distance fiber optic networks represents an enormous challenge. If we send single photons over 1000 kilometers, even at rates of 10 gigahertz, we would need to wait hundreds of years to detect just one due to loss on the fiber. Not very practical. Modern telecommunication overcomes this problem with amplifiers that boost the signal along the way. However, this would destroy the quantum characteristics of photons, such as the entanglement, and even in principle, this photon information cannot be copied. We call this no cloning. Therefore, quantum approach to overcome transmission loss is required, the quantum repeater. There are many future directions in quantum networking and internet networking, but now it is a very time-taking process. So we need to try 4 more years so that we can be reliable on that, and it should be very murky. Thank you so much. This is Chupak signing off from roll number 2295196216 CAC Cybersecurity IARE, and the subject was Applied Physics.